This lesson deals with supplemental problem 312. You can find this problem in the ECE201 ebook in the Chapter 3 Supplemental Problems on page 12. Suppose we have this circuit and we want to maximize the power transferred to this 10 ohm resistor by varying the value of R here. What's the value that I would need to get the most power here, and then how much power would be delivered to it? So we had two theorems dealing with maximum power transfer. One where we're finding the power to a load, where we're adjusting the load. And that's where you make the load equal to Thevenin resistance. Our other theorem was on the maximum efficiency theorem, and that says that if you can vary the Thevenin resistance, make it equal to 0. So let's try that in this case. Let's find the Thevenin resistance seen by this 10 ohm resistor. We're going to take the load off, set all the independent sources equal to 0. That's going to short to 12, short to 8. We're going to look into these terminals, and what I see is R in parallel with 20. So that's going to be the product over the sum. I want to make that as small as possible, and by making R Thevenin equal to 0, that means that R would be equal to 0. So if you could make that resistor 0, let it be that value. Now if you do that, then you have a short circuit here, and this node voltage is sitting at 12 volts, and this node voltage is sitting at 8. So the voltage across the 10 ohm resistor in this direction would be equal to 12 volts at this node minus 8 volts, or 4. So the power to the 10 ohm, and that would be V squared over R, and that would be 16 divided by 10, or 1.6 watts. Again, what we're doing here is varying the Thevenin resistance to get the most power to the load. Take a look in Chapter 4 at a circuit that actually can have its output resistance shrunk to a very, very small value. And this is supplemental problem 312.